So yeah, hi guys, this is the follow-up video to our current series that we are having. We are just doing our class 9 mathematics, right? So this is because we are going to continue with that series, and now I have this chapter for you guys. This is your chapter 2, polynomials. This is very easy chapter. You guys should be knowing half of this chapter previously from your previous knowledge. You guys would be able to just recall each and everything that this chapter has to offer. There are some concepts that are related to your class 8, so I will be having those concepts revised once in the beginning of this video. Then I will be telling you what new concepts do we have in this, so we are going to follow with that one, and I will be having some interesting new tricks here which you can use to in order to solve your answers. So let's just start with the video and see. Introduction. So we have the very first introduction. You guys see we have what? You guys already remember each and everything that we have already learned in a class 8, right? So you guys should be understanding what are algebraic expressions, right? You guys should remember that. So what are algebraic expressions? So you guys remember those are what? Those are your constants, your variables, and your coefficients. When you use all these three in the form of terms and you have some operators in between them, those become your algebraic expressions, right? If you guys remember 2x plus 1, this is your algebraic expression. You guys see we have a coefficient 2, a variable x, and a constant value 1. So algebraic expression itself is what? Algebraic means when you have a statement in the form of alphabets and numbers. When you use both of these to denote some quantity whose quantity is actually not known to you, but you just assume that it has to be that, so that kind of equation is what? That kind of expression is actually your algebraic expression. Let's say if I ask you, if I tell you I have some mangoes with me, you guys would be guessing, you guys don't know actually how many mangoes do I have, but you guys would be assuming that I will be having some mangoes. So let's say I have x mangoes. So this x is what? It is a quantity which is denoting an abstract quantity which has not been given to you. This is a quantity which has not been disclosed yet, but you guys know that should be present while you are assuming anything. So algebraic expressions come handy while you are dealing with your linear equations, mostly your linear equations. See, difference between an expression and an equation is what? Expressions generally do not have any value. They don't give you any output. They don't give you any result. They just give you the mathematical expression of a written statement. Let's say if I give you an example here, you guys will be recalling each and everything then. Let's say if I tell you I have twice, let's just not use this 2, twice the mangoes that my friend has. So this means if my friend has x mangoes, I will be having twice of that. That means 2x. So this is generally a written expression of whatever you are having as a statement. So this is just the written expression of the statement that is given to you. It does not give you any finite value. And let's say if I just tell you, let's say if I just complete this statement and tell you, I have twice the mangoes that my friend has, and together we have, let's say, 30 mangoes. So this means if I add the number of mangoes that I have and the number of mangoes my friend has, together they are what? They are 30. So you guys see, this is what? This is giving you a finite value, and this is an algebraic equation, or you can say this is your linear equation. So just a difference between your equation and expression. Difference is pretty straightforward. Expression does not give you any result or any finite value, whereas equation is giving you exact value. And you guys see, equation means equal. You have an equal sign here, so you should be having some values while you are having an algebraic equation, but for the case of expression, you won't be having any value. And you guys remember we had used these identities in order to solve our algebraic expressions, in order to factorize them. So I will be having a factorization session also, but for now I will be having what this chapter has to offer. While we are on a practice session, I will be having some factorizations also, because this chapter includes factorization. So while we are typically on our polynomial, I will be having factorization then, but for now we don't have to go there. If you remember that, that is quite brilliant. If you don't, just don't worry, I will be explaining it to you. So these are some identities right in front of you. Your first one is a plus b's whole square. You guys remember a square plus b square plus 2ab. A minus b's whole square, that is what? A square plus b square. minus 2ab. Now if you had this one, a plus b into a minus b, that was a square minus b square. You guys should be recalling that one, right? And then you had a plus b plus c whole square. That means square of three different variables or three different values. Addition together, they will be giving what? An a square and a b square and a c square adding together plus 2ab plus 2bc plus 2ca. So that is what? That is your identity here. Now for the case of your last one, if you have something like this, x plus a into x plus b, that will be what? That will be x square plus a plus bx plus ab. These are some identities, you guys should be recalling them. Now I will be coming to this point here, polynomial, in a bit. So just remember, you just have to understand what are algebraic expressions. Every expression can have, algebraic expressions are divided into various parts, or each of them has a definite name, like your monomial, your binomial, or trinomial, your polynomial. So you guys get an idea. Algebraic expressions are categorized into various groups. Each of them has a finite name. So I will be telling you which group has which name. So let's just move forward with this. I hope you don't have any doubt in this. So starting with this one, I have what? I have some basic terms for you guys, are constants and variables. You guys see what are variables? Variables are generally your alphabets, or you can say variables are those values which are not fixed. If you guys remember, I had taken an example, right? I had some mangoes with me. So I had chosen a variable x for the number of mangoes that I had. You guys see, I did not disclose how many mangoes do I have. So you guys see, this is what? This is a variable and it is denoting some value which is not fixed. So variable themselves should be denoting some values which are not fixed. So generally we consider our alphabets as our variables. So any alphabet that you deem fit, that can be your variable, right? Now the difference, now we come to the point of constants. So what are constants? You guys see, constants are what? From the name you guys can get an idea that constants are those values which are fixed, which cannot change, like any number, any natural number or whole number, like 2, 3, 4, even rational numbers also, even your irrationals also. Those are what? Those are your constant values, right? Square root 2, it is a fixed value, right? It is a fixed value, although it is non-terminating and non-repeating, but none of the other irrational numbers should be having the same decimal expansion. That is the whole point here. So constants are fixed. So you guys see, 2 is a finite value, 3 is a finite value, 4 is a finite value, minus 1 by 2 is a finite value, minus 3 is a finite value. So you guys see, your constants are generally fixed values, and variables are those values which can be altered at any given statement, or they change with any particular value. For example, if I have something like this, let's say x plus 2 equals to 5. So you guys see, x will be 3. If I had taken x plus 2 to be 4, x would have been 2. So you guys see, a value of x is not fixed, it is changing with every other value. So this is the whole point of variables. They can have different values at different aspects of the equation. So that is the whole point here. So you guys see, I have an example for you guys. It is this one. Let us assume the side of a square as a units. There is a square whose side is a units. So you guys see, the parameter will be 4, and you guys see 4 will be the parameter will be changing with every value of it. If you put a to be 1, if you substitute a to be 1, your parameter will be 4 units. Then if you substitute it to be 2, your parameter will be 8 units. So you guys see, the parameter will be changing since you have assumed a variable as its length, or you can say its length is variable length. So it is not fixed, it will be keeping on changing with every new value. So that is the whole point of constants and variables. I hope you don't have any doubt in this. So that is the whole point here. Using your constants and variables along with your coefficients, you get your algebraic expressions, and you can say your polynomials. So let's just move forward, and we have the term algebraic expression now. So you guys see, I have already disclosed this one to you. So you guys already know the combinations of constants, variables, and your coefficients connected by some operators, let's say multiplication, addition, division, or subtraction, that becomes an algebraic expression. You have your expressions here: x square minus 4x plus 3, x plus 2, y plus 9, x square plus y square, 9x plus y. Anything, any equation that you want to write, if it does not give you any finite value as the answer, that expression, if it has variables, coefficients, and some constants, there can be constants. You guys see, we do have a constant here which is 0. So you guys see, combination of constant, variables, and coefficients, that becomes an algebraic expression as long as it is not giving you any finite value. If it does give you a finite value, that will be your algebraic equation. I hope you guys understand this, right? Now let's see, what do we have for the next part? It is this one: terms of an algebraic expression. terms are what? Terms are the part of an algebraic expression which are separated by either a positive sign or a negative sign. Remember, if I have something like this, let's just erase this one. If I tell you we have to find out terms of an algebraic expression, so you guys see, I will be considering this example here, which is this one, x square minus 4x plus 3, right? So you have to find out the terms, right? Always remember, terms are separated by your positive and negative operators. So you guys see, I have this negative sign here, I have this positive sign here. So this should be term 1, that should be term 2, and that should be term 3. Keep in mind, they have to be having different values. You guys see, I have an x square here, I have an x here, I have a 3 here. If I had something like this, x square minus x square, you guys see, we do have two terms here, but their answer is what? It is 0. So technically we just have only one term. So that is the whole point here. You just have to look for the terms and they have to have different values. So you guys see, we have an x square here, we have a negative 4x here, and we have a 3. So always remember, a general form of any equation or any expression, it is like this. If it is a quadratic equation, it will be like this: ax square plus bx plus c. Always remember, there should be a positive sign in the middle. If there is any other expression, you just have to make sure that you have only positive signs in between the terms. There can be negative sign, but that negative sign will be the part of your coefficient or the term. Now you can look here, we have this equation, right? X square minus 4x plus 3. So I had told you we had three terms here. First one was x square. Next, you guys see, I have negative 4x. I had used this term, negative 4x. So my next term will be negative 4x. It will not be only 4x. We will be having this negative sign with our term. So exactly our equation is looking like this: x square plus minus 4x plus 3. So guys see, my first term is x square, my next term is minus 4x, and my third term is 3. So this is the constant right here. This is having a variable x square, this is having a variable x, and the numerical value that is with your variables. Let's say if I just write it here, if I just assume my x square, you guys see this x square is what? It is variable, right? And the numerical value which is attached to your variable, that is what? That is your coefficient. So in our case, we don't have any value here, right? We just had only x square. So if we don't have any coefficient, that means we only have 1 with it. So in this case, our variable is what? Our variable is x square, and our coefficient is what? It is 1. So we are going to come back to this concept later on. So just remember, these are the cases of your variables and coefficients and everything. I will be having a dedicated point just in a bit. So just keep in mind. So polynomials. So polynomials are what? Polynomials, an algebraic expression in which the variables have only non-negative integral powers, are polynomials. So polynomial is basically any algebraic expression. Remember, any algebraic expression, keep in mind, any. It does not have to have more than 3 power or 2 power. Any algebraic expression which has just its power which is non-negative. Remember, its power cannot be non-negative integral power. That means it has to be what? A positive integer. Or if I tell you, it has to be a whole number. That is simpler to understand. So remember, any algebraic expression in which the variables have whole powers, they don't have any negative power or powers in fraction, that will be a polynomial. Remember, their power even cannot be in fractions. That means there cannot be an incomplete squares or cube roots or quad roots, anything like that. Their power has to be whole. Now you can look here. We have our first example right here. You guys see, each and every power is in whole number. I will be explaining it here. This is actually x raised to power 0. You guys remember from your previous chapter, in a last portion I had some your laws of exponents, right? There we had this term, if a had any power 0, that was what? That was 1. So you guys see, if I pick this 3 up, let's say if I erase this and pick this negative 3 up, can I write it like this? 3 into 1, obviously it will be negative 3, right? And since our whole equation has just only one variable, it is sharing just x with different powers. So can I write this 1 like this? 3 into x raised to power 0. So technically you guys see, each and every power is in whole number. It is not negative, neither it is 0, neither it is in fractions. See, you guys remember, whole numbers are 0 and up to so on infinity. So your variables can have any power, but that power has to be a whole number. That is the whole point here. So guys, see, this is a polynomial with one variable x. Now if you look at your second part, you have 3 here, you have an x square here, you have x square y here, which generally has a power 1. You guys remember, if we don't have any power, if I have just a, that means its power is 1, right? It is only 1 here. So whole point here, 6x square y and 5x y square. You guys see y has a power 1 again. So you guys see here again, each and every power of a variable is a whole number. So that means this is indeed a polynomial. Now you guys see, we don't have only one variable here, we have two variables. So this is a polynomial in two variables, right? Yeah, two variables, x and y, right? Now let's just see our third example here. We have what? 5 plus 8x power 3 by 2. You guys see our power of x is in fraction. That means it is an incomplete square root. It is actually like this, x cube and a square root. So square root of x cube, this is what? This is an incomplete square because it will be x root x, right? That is the whole point here. So it is not a polynomial like it has been mentioned here. It is not a polynomial since the term is considering what? It is having a power which is in fraction. It is not an integer. Remember, it has to be an integer, but remember that cannot be a negative integer also. It has to be a positive integer, or if you can't remember integers, just remember you have to have whole numbers. That is quite easy to understand. So remember, polynomials are any algebraic expression whose variables have a positive power, or you can say whose powers are always whole numbers. That is the whole point here. Now if you look at your fourth part, you have what? You do have a 5x square, but you do have a 6x raised to power minus 1, or you can say 6x inverse. So you guys see its power is not positive, so it will not be a polynomial because its power is negative. So that is the point here. The polynomials will always be having positive powers. So I hope you guys understand this. That means they will be having whole numbers. That is the whole point here. Now let's just move forward with this. So we have the coefficients here. Coefficients are what? These are generally your constant values which are attached with some variables, so that they alter the values with every given point. Let's say if I have 2x, with every different value of x, I will be having some different answer. So this 2 is a finite value, it is a fixed value, but since x is not a fixed value, so it is the coefficient of x. That means it is the partner of your x1, or you can say coefficients are generally the partners of your variables. So they help to have different values. They just alter the values with every different value of your variable. Now if you consider this example right here, 5x cube minus 4x square minus x minus 3. So you just have to find out the coefficients of x cube, x square, x and 3. For this, let's just find out the number of terms here. Firstly, let's find out terms. So you guys see, this will be term 1, this will be term 2, this will be term 3, and finally our term 4. So our first term, we have what? 5x cube. We have to find out the coefficient of x cube. So you have to do what? Just pick your term which has an x cube with it, divide it with your x cube, whatever you're left with, that will be your coefficient. So that is what? That is 5. Or you can just simply look for it. So you guys see, this is x cube term here. So its numerical partner will be what? It will be your coefficient. So coefficient is what? It is 5. That is written here. Now if I want to find out the coefficient of my x square, you guys see, I had told you negative sign will be with our term. So this will be negative 4x square. So if I have to find out the coefficient of x square, if you can look for it, this is negative 4. That is the coefficient here. That is the numerical part. Or you can do what? You can just divide this for negative 4x square with x square. So whatever left is your coefficient. So that is what? That is your negative 4x. And remember, it is not necessarily fixed that you will always be having some constants as your coefficient. You can have something like this also, negative x square y. Let's say if I wanted to find out the coefficient of x square, so you have to do what? Just remove whatever whose coefficient you want to find out. So I will be dividing this, let's just erase this one, and I will be doing what? I will be dividing this equation with the coefficient that is required, with the variable whose coefficient is required. That means I will be dividing this with x square. So if I divide this, I will be having a negative y. That is what? That is also a coefficient. Don't get confused. It is a variable, but that is acting as a coefficient to your x square. And the other way around, if you had something like this, negative x square y, and if somebody had asked me to find out the coefficient of y, that would have been negative x square. So you guys see, coefficients can most of the times are your constant values, but that is not necessarily fixed that they will always be constant values. There can be variables also which will be acting as your coefficients. So remember, coefficient is generally the partner of your required variable. So that is the whole point here. Now coming back to the concept here. So quickly, we have coefficient 5, we have coefficient -4, we have coefficient. Now here I don't have any variable, so sorry, any constant value, right? I had just -x, I did not have any coefficient. So my coefficient will be what? It will be 1. So our coefficient actually is what? It is -1. Now for -3, this entire term will be your constant value. Now here I have some point for you guys. If they had asked you to find out the coefficient of x raised to power 0, how would you have done? How would you have found out? So you would have found it like this. See, if I have done it like this is my -3, right? Can I write it like this again, multiplying with 1? This will be -3 x raised to power 0. So now you guys can see our actually x raised to power 0 is what? It is 1. So you just have to find out the constant value that is given to you. That will be the coefficient of x raised to power 0. That is the whole point here. And just keep in mind, I have one more example for you, which is this one. So you guys see my value is this one. I will be writing it here. 5/3 x square -√2x and a +3. Now firstly, let's find out the number of terms that we have here. This is our term 1, this is our term 2, and this is our term 3. Correct? To find out number of terms, firstly observe, our each and every term should be having different powers of the variable or different variables in it. So you guys see, I do have similar variable which is x, but powers of that x are different. So I will be doing what? Counting the number of signs in the middle or operators in the middle. I have 2 operators here. So our number of terms will be what? 2 plus 1, that will be 3. So I should be having 3 terms here. And you guys see, we do have 3 terms, 1, 2, and 3. So that is the point here. So if I just look at our first term, you guys see I have 5/3 x square. So if I want to find out the coefficient of x square, that will be what? 5/3. If I want to find out the coefficient of x, that will be what? -√2 or √2? Tell me, what will that be? A -√2 or just a 2? Obviously, you guys remember, we have to consider negative with the coefficient or the term. So that means it will be -√2. And for the constant value, we have 3. So here you guys see, our coefficients can be incomplete square roots, our coefficient can be in fractions, even coefficients can have negative powers also. If I write something like this, 2 inverse x, this is actually what? x/2. It does not matter whether the coefficient is in fraction or not. It can be in fraction, it can be negative number, it can be an irrational also. But always remember, your variable portion has to have whole numbers as its power. It has to be risen to the whole powers. So that is the whole point here. Now we are going to come to the concept of our degrees. So you guys see degrees of polynomials. What is that? If you want to find out degrees of polynomial in one variable, always remember degree is actually the maximum power that the given algebraic expression shares. Now if you look at this one, we have this one, 2x plus 1. This is what? This is a linear equation, or you can say this is a polynomial with variable 1 and only one variable. So you guys see, if I want to find out the degree, you guys see the maximum degree is what? It is 1. So its degree is what? It is 1. Now if I look at this one, so if I have something like this, 5y³ minus 4y square minus 4y plus 1, or you can say y minus 3, whatever that is. If you want to find out the degree here, you have to look for the maximum value that variable is having. So you guys see, y is being raised to a maximum power of 3. So degree is what? Degree is the maximum power. It is what? It is 3. So you guys see, in our first case degree was 1 and in the next case degree was 3. Now you guys see, here I have some more concept for you. If you want to find out degree of polynomial with 2 or more variables, then you have to look for that common term which is sharing the both variables, and you have to add their powers. Like if I have something like this, let's say this is the case, 7x³ minus 5x² y², and let's say plus 3xy plus 6y plus 8. Now you guys see, if you look at this, honestly you guys see, we have a maximum power of 3 because this is 2 and this is 2. These are less than 3, right? So you guys should be telling me that sir, degree is actually 3, but that is wrong. While you're dealing with more than one variable in your polynomials, you just always have to look for, firstly obviously look for the maximum power. If you get a maximum power like I did, it is 3 here, right? Just pause here and let's just cross verify with that term which is sharing the both variables, or which is having the both variables here. Now you guys see I have two terms here. First one is minus 5x square y square and another is 3xy. So you have to do what? You have to just verify either these. If you add up their powers, the variables there, if you add their powers, if you get a number which is more than the given degree, that means the degree will be that number. Like if I just add this 2 and 2, actually I will be getting a 4, and you guys see 4 is greater than 3. So its degree will be what? It will be 4. You guys see they have a power 1 and 1, so it should be 2. It does not matter, we don't have to consider this one, but I will be getting this one. So x square y square, adding their powers, that means square and square, I will be getting a power 4 or degree 4. So its maximum degree is what? It is 4. So you have to just look for the maximum degree like this while you're dealing with one or more than one variables here, right? So that is the whole point. Now let's see what do we have next. So these are some practice questions for you guys. We have to separate our coefficients and variables. You can do this quickly, so just do this with me. You have your pens and notebooks with you. So in our first term, firstly observe, do we have different variables or do we have similar variables? So guys see, variables are similar but their powers are different, so we will be having different terms. So first term is what? 2x cube. Then the next term will be what? 3x square. A third term will be what? We do need to consider our negative with the term, so it is what? Negative 3x, and a fourth is what? It is constant. So you guys see, if I just separate the coefficients here, variable is x cube, coefficient is 2. Variable is x square, coefficient is 3. Variable is x, coefficient is negative 3, and in this case this is constant. Or if you want to write it like that, so variable will be x raised to power 0, coefficient will be 11, so you can write it like this also, right? Easy. Now let's see, if I erase this and start with the second one, you guys see, term, first term x square, second term negative 11x, and third term 1. Variable x square, coefficient, it does not have any coefficient, that means it is 1. Variable x, coefficient negative 11. Now in this case it is constant, or you can do it like this, variable x raised to power 0, coefficient 1. So that is the whole point here. Similarly you can do this one. So terms will be 3x square y square, 2x square y, 2xy square. So this will be what? Variable x square, coefficient 3, variable y square, coefficient 1, variable x square y, coefficient 2, and variable xy square, coefficient again 2. So you guys see, these are very simple, right? And in this case, x is variable, coefficient is 1, y is variable, coefficient is 1. And in this case, don't get confused here. If you want to find out the coefficient of x, it will be y in this case. If you want to find out coefficient of y, it will be x. If you want to find out coefficient of both x and y, that can be 1, right? And in this case, variable is x raised to power 0, coefficient is 1. So these are the cases here. I hope you guys have understood this and you don't have any doubt in this. So these were some questions for you. Now let's move forward and let's understand what are actually our monomials, binomials, trinomials on the basis of our degrees. So let's just jump forward. So you guys see, I have polynomials with various degrees here. So linear polynomial. What is linear polynomial? Linear polynomial is that polynomial which has a maximum degree of 1. Or you guys can see, this is a linear polynomial. Any polynomial in which the degree is 1, that is your linear polynomial. Linear means 1. Quadratic. Quadratic means any polynomial which has a maximum degree of 2. That is the whole point here, right? This is your quadratic polynomial. And sometimes you should be having something like this, x4 minus x square plus 2. So don't get confused here. This can be your biquadratic or it can be your quadratic also. How? If you just assume this one, let's say, can I write it like this, x square whole square minus x square, its power 1 and 2. If I assume x square to be t, this is what? T square minus t plus 2. So if you refer this as your another term, that will be a quadratic, or you can write it like this. If you observe it as it is, if you have the maximum power 4, that will be a biquadratic. Bi means 2, and you guys see we have just done 2 steps here. And for the case of cubic, cubic is what? Cubic is that polynomial whose maximum degree is 3. So that is the whole point here. Linear means 1, quadratic means 2, cubic means 3, and biquadratic means maximum power 4. So I hope you guys understand this and you don't have any doubt on this, right? Now let's move forward. So we have to find out degrees in each of the following polynomials. Quite easy, you guys should be able to solve this one. So you guys see I have this x raised to power 5 minus x square plus 3. So we have to look for the maximum degree. You guys see maximum value is what? It is 5. So degree is what? Degree is 5. And in this case, you guys see each of them is sharing the same term but different powers of that. We have to look for the maximum degree here. Maximum degree is what? It is 8. So it is what? 8. Now in this case, you guys see we don't have any variable. Or do we have? Think. Yeah, we do have. It is 2 into x raised to power 0. So its maximum degree is what? It is 0. Since, or you can say we don't have any variable here, so its degree has to be 0. And you guys can think it like this: x raised to power 0 is actually 1, so it is 2. So that means its degree should have been 0, so its maximum degree is 0. I hope you guys understand this and you don't have any doubt here, right? Now let's move forward. It is this one: number of terms in a polynomial. So now we are going to find out how many terms can there be and what are the names of those expressions. If you are referring to your monomial, monomial means one term. So in any expression, if you have just only one term, that will be what? That will be your monomial. If you have something like this also, 3x plus x, this will be what? This, if you look at this, it has two terms, but its answer will be what? 4x. So this is what? This is actually a monomial. Now for the case of binomial, binomial has two terms, and you guys can look here, negative 2x plus 3b. So you guys, this will be what? These are sharing different variables and different terms. So this is what? This is your binomial. Binomial means 2. And trinomial, trinomial means 3 terms. So you guys see we have 3 different terms here. So these are what? These are the general names or the number of terms in a polynomial. Monomial has 1 term, binomial has 2 terms, trinomial has 3 terms. If you have anything more than 3, just name it as your polynomial, right? Now for the case of constant polynomials, so what are constant polynomials? Constant polynomials are just those polynomials which do not have any variable with them or whose maximum degree is 0. Like if I tell you 2, this does not have any variable with it, or you can say the variable it has a maximum degree of 0. So this is what? This is your constant polynomial. Constant polynomials are your constants. Remember, they are only constants. If you have any variable attached to that constant, that will be what? That will be a monomial. So remember, if there has been given something like this, what is 2? And they have given you options: monomial, constant, polynomial, binomial and trinomial. You guys see, this cannot be your monomial because it has to have a variable with it. It does not have any variable on our first look. That will be what? That will be a constant polynomial. Understood? Now for the case of zero polynomial, zero polynomial is what? It is actually that polynomial which has only one term and that term is 0. Remember, if you have been given any 0 and they had asked you which kind of polynomial is that, they have given you various options: constant polynomial, monomial, zero polynomial or binomial. Then remember, this is not constant polynomial, this will be termed as your zero polynomial. Also, although the value of 0 is fixed, but it has a special name. It is what? It is zero polynomial. So remember, if you have any 0 and they are asked you to name that polynomial, that polynomial will be zero polynomial, and any other value apart from that 0, that will be a constant polynomial. If that happens to have a variable with that one, that will be a monomial. So remember, monomial, binomial, trinomial, each of them will be having some variables in them. If you don't have any variable, that will be a constant polynomial. If that polynomial has a value only 0, that means that is zero polynomial. And I have a point here: the degree of zero polynomial is not defined. Why is that? See, if I have 0 here, you guys see, if I multiply 0 with x raised to power 0, that means 0 with 1, answer will be 0. If I multiply 0 with x raised to power 2, answer will yet be 0, because anything multiplied with 0 will give you 0. If I multiply 0 with x raised to power infinity, which is actually not possible here, but let's say if it is the case, you guys see, if you multiply these two, your answer yet will be 0. So you guys see, for any degree of x, your answer is remaining 0. So that means degree cannot be defined here. So any degree that you want to find out for 0, that will be not defined, or you can say infinite. Actually, the correct term would be not defined, but if you can use infinite, then you can use that one. But remember, degree of 0 is not defined. That is the point here. I hope you guys understand this, right? You don't have any doubt in this. Now let's move forward and see our exercise 2.1. So, which of the following expressions are polynomials in one variable and which are not? State your reasons. You guys see, we have this one 4x square minus 3x plus 7. Power is whole, and this is constant. This will be true. So this is what? This is a polynomial. And here, you have your y square and a square root 2. It does not matter what is the value of your coefficient or your constant. The variable has to have a power which is either 0 or a whole number. So you guys see, that is the case here. This is also true. But in this case, you guys see, t is sharing an incomplete square root. That means it is actually having a power which is in fraction 3 t raised to power 1 by 2. This cannot be a polynomial because the condition is that polynomials have to have whole numbers as their power. So that is the whole point here. Now if you look at this one, you have what? Y plus 2 by y. If I write it like this, this will be like this, y into 2y inverse. You guys see, its power is whole, but its power is what? It is negative, and this cannot happen. Power has to be a whole number. So this again will not be a polynomial, right? You guys can understand this, easy. Now for the last one, you have this one, whole number, whole number, whole number. This is 2. So out of each and everything, this is polynomial, this is polynomial, this is not polynomial, this is not polynomial, this is a polynomial. So that is the answer. These are the answers to your first question. I hope you guys have understood this, right? Now let's just jump with the second exercise, second part of this exercise. So we have to find out coefficients of x square in this. So we have 2 plus x square plus x. We need to find out coefficients of x square. Quite easy. You can do what? You can just find out the term which is actually having a variable which is x square. So you guys see, this is the term. So our term is x square. We don't have any coefficient with it. So that means its coefficient is what? Coefficient is 1. In this case, we have what? 2 minus x square plus x cube. You guys see, this is the term which is negative x square. We do not have any coefficient. That means we have a 1 here. So coefficient will be what? It will be a negative 1, right? In this case, we have what? We have this pi by 2 x square plus x. This is the term which is containing x square. We have to find out the coefficient. This will be what? Pi by 2. So coefficient is what? It is pi by 2. And in the last case, look here, we have this one, square root 2x minus 1. Now we do have to find out the coefficient of x square, but I cannot see any x square here, do I? So can I write it like this? 0x square, because we can add a 0 to it, right? And anything multiplied with 0 will be 0. So its coefficient is what? 0. Or you can just simply say we don't have any x square, so coefficient has to be what? It has to be 0. So that is the whole point here. I hope you guys have understood the case and you don't have any doubt in this, right? So easy exercise. Now let's move forward. So we have this one. Give one example each of binomial of degree 35 and monomial of degree 100. We have to have binomial of degree 35 and monomial of degree 100. So you can write it like this, 3x whole power 100, that is your monomial. Or you can take it like this, 3t 100, 3z 100, 3w 100, 1 by 2w 100, any value. Just remember, it has to have only one term and it has to have only one variable. So that is the whole point here. Even you can have two variables also. See, 1 by 2, w50, p50. Together their degree will be what? It will be 100. You guys have just understood this, right? So this can also happen here. Now we have to think of binomial of degree 35. So it has to be a binomial. So it can happen like this, 3x 35 plus 1, or 3x 17 into y 18 plus 1. You can have any value, right? Understood? So that is the point here. You can write any equation that you want. Just remember, it has to be a binomial, so it will be having two terms and it has to have a maximum degree 35. So you guys see, some of these will be 35. This is exactly 35. Here you have to have a monomial of degree 100. So this will be 100. Or some of these two will be 100. So you need to have only one variable, sorry, one term. So I hope you guys have understood the case, right? So that is the answer to your third question. I hope you don't have any doubt here. Now let's just move forward and let's just see. We have these. We have to write the degrees of each of the following polynomials. Quite easy. You guys should be able to solve this one. Maximum degree 3, maximum degree 2, maximum degree just a 1, maximum degree 0. Don't ask me why, I have already explained this one, right? So 3 into x raised to power 0. So maximum degree is what? It is 0. So you guys understand that, right? Quite easy. Now let's move forward and see what do we have now. So we have to classify these as your linears, quadratics, cubic polynomials. So you guys see we have two terms, both of them have different powers or degrees. So you guys see this is what? This is your quadratic and its maximum power is 2. And you guys see we have what? X minus x cube, maximum power is 3. It is what? It is cubic. Y square 4, maximum power is 2. It is what? Quadratic. Maximum power is 1. It is what? Linear. Maximum power is 1. Linear. Maximum power is 2. Quadratic. Maximum power is 3. Cubic. Understood? If you have 2 as the maximum degree, that will be quadratic. If you have 1 as the maximum degree, that is linear. If you have 3 as the maximum degree, that is what? That is your cubic. Understood? So very easy. You can easily do these. Now let's move forward. We have now the concept of zeros of polynomial. So this is the topic here. I want you guys to understand this one because our initial part of the video had not typical portion. This is the concept here which from where our chapter actually begins. So keep an eye on this one. So we have what? We have this one. Thank you, Kushal. So see, zeros of polynomial. What is actually 0? 0 is 0 of a polynomial. What is that? Actually, when you have any polynomial, let's say if you have any polynomial, let's say this is 1, 2x plus 5. Let's say this is your polynomial right here, your binomial term. If you want to find out the 0 of this polynomial, just remember, you have to substitute x in such a way that after putting that value in this equation, your p of x, remember if you want to denote your polynomials, always remember they are denoted with the p of x. That means polynomials in term of x, let's say it is 2x plus 5. So in order to find out our 0 of polynomial, we have to do what? We have to substitute x to get a value which should be giving me an answer as a 0. So at any given value of x, if your whole polynomial becomes 0, that value will be the 0 of polynomial. The simplest way is what? Just pick your polynomial. In our case, we have this one, 2x plus 5. Put it against 0. Calculate the value of calculate the value of x like you solve a linear equations. So you guys see 2x equals to negative 5. X will be what? Negative 5 by 2. So that is the 0 of polynomial. So in order to check, let's just replace this value here. 2 into negative 5 by 2 plus 5. You guys see this will be cancelling out. I will be having a negative 5 and a 5. Both of them will be adding up to 0. So you guys see we do have a 0. So in short, x equals to negative 5 by 2. That is a 0 of this polynomial. So that is the case here. So this is the whole point here. If we have p of x is a polynomial such that if I replace x with any finite value n and it ends up being 0, so that n is the 0 of polynomial. So that is the whole case here. I have taken examples also. So this is the point. Remember, this is how you're going to do this one. But let's say if we have a quadratic equation here. Let's say if we have something like this, 2x square and let's say we have 3x and 1. We have to find out 0 of this polynomial. Although this is the concept of your class 10, but let's just say if that has been asked in your exams also. Firstly, let's just name this polynomial as p of x. Now we have to do what? We have to find those values of x on which its answer is 0. That means our p of x is giving me 0. And remember, as many whatever the maximum degree is there, that will be the number of zeros you will be getting. In our earlier case, we had what? 2x plus 5. So its maximum degree was what? So only 0 that we could have here, it was what? Minus 5 by 2. So we could have only 1 0 here. But in this case, we have a maximum degree 2. So it can have at most 2 zeros or it can have no zeros. There are various cases. You will be understanding this concept in class 10. But for now, you have to do what? Just factorize this equation. So remember, I had told you that I will be having this concept where you guys will be understanding factorization also. So do you recall this one? If you compare this with ax square plus bx plus c, you guys see I have to substitute this in such a way that bx should be broken down into two parts such that their addition will be giving me 3x and multiplication of those will be giving me a 2x square, which is actually what? 2x square into 1. So that should be what? That should be ac x square. Easy, you guys should be thinking of the factor that will be what? 2x square plus 2x plus x plus 1. So guys see 2x plus x, 3x, 2x into x, it will be 2x square. So you have your factors which are what? 2x square plus 2x plus x plus 1. Take common 2x from here, you will be having what? X plus 1. Take just 1 common here, you have x plus 1. So your factors are what? 2x plus 1, x plus 1. Now you have to find out zeros. Just do what? Put it against 0. Firstly assume this 1 0, then assume this 1 0. So when you put 2x plus 1 equals to 0, x will be what? It's 1 by 2. When you put x plus 1 to 0, you will be having x equals to minus 1. So this equation, our equation 2x square plus 3x plus 1, it had two zeros which were a negative 1 by 2 and a negative 1. So these are kind of things that you should be remembering if you remember your factorization. So this is how you're going to find out zeros of polynomial. There can be any value that you want to find out. So that is the whole point here. So zeros are generally those values on which your polynomial becomes 0 itself after you have replaced your x to y to any finite value. So that is the whole point here. So we have some questions. So you have to find out the value of polynomials at x equals to 1. Just do what? Replace your x to be 1. So p of 1. Thank you, Aaron. So देखो, if I put x to be 1, it will be what? 5 into 1 whole square minus 3 into 1 plus 7. So if you solve this, you have what? 5 into 1 minus 3 plus 7. 5 plus 7, 12. 12 minus 3, that will be 9. Similarly, you can do this one. Similarly, you can do that one. So easy, right? So if you want to do the second part, you guys should be doing it like this. 3 into 2 whole cube, replacing x to be 2, sorry, y to be 2. 3 into 2 cube minus 4 into 2 plus root 11. You guys see we have root 11 here, so its answer will not be any finite value. We will be having this irrational part there. Although it will be finite, see, it will be this one. 2 into 8, that will be 24 minus 8 plus 11. So it should be what? 16 plus root 11. So that is the answer. Similarly, you can easily do this one. But in this case, you guys see, you are replacing t to be any other value, which itself again is a variable. So its answer will be variable itself. So your equation just be looking like this. 4 into a4 plus 5 into a cube minus a square plus 6. That will be the answer of your last part. You can just solve this one on your own and you can just let me know if that is not the answer. This will actually be the answer here. So now let's move forward and see what do we have in our example 5. We have this one. Verify whether 2 and 0 are the zeros of polynomial. So you have to check whether it is 0 or not. Firstly, you have to do what? Just name your given polynomial p of x, which is equal to what? X square minus 2x. If it had been y, then we would have named it like this, p of y. Remember, whatever variable you have to put it here. Now you have been given two values, right? 2 and 0. Firstly, do what? Put x equals to 2. So p of 2, that will be what? 2 square minus 2 into 2. This will be what? 4 minus 4, that will be 0. This indeed is a 0 polynomial, right? Because you have got an answer which is 0. Now do what? Just replace the value with x equals to 0. If I put x equals to 0, you guys see this will be 0, this will be 0. So it will be what? P of 0 itself will be what? 0 square minus 2 into 0. It will be what? 0. So both of these values are what? Both of these values are zeros of your polynomial, right? Easy. So that is how you are going to attempt this one. Easy, right? Now let's move forward. So these are exercise questions for you guys. We have this one. Find the value of polynomial at x equals to 0, x equals to negative 1 and x equals to 2. Quite easy, you just have to replace the values here. So you should be doing this easily on your own, right? Now for this one you have what? Find p of 0, p of 1 and p of 2 in each of the following polynomials. So you have these polynomials, you have to find just these values. Let's say if I pick my fourth part, we have this one. P of x, which is what? X minus 1, x plus 1. Firstly solve this one, a minus ba plus b. A square minus b square. That means it will be what? A square minus 1. Now this is what? This is your p of x. Now you have to find out the value of p of 0. So p of 0 will be what? 0 square minus 1. That will be what? Minus 1. Now if you put p of 1, square of 1 minus 1, that will be what? 1 minus 1. That will be 0. Now if you just move forward, you put p of 2. That will be what? Square of 2 minus 1. That means 4 minus 1. That will be 3. So this is how you are going to attempt each and every part in this. I hope you guys will be able to solve this one, right? So this will be your homework as well. You will be attempting these 3 questions on your own, right? Along with those 3. Now let's see what else do we have in this exercise. So this is the case here. You have to just find out whether the given values, the given zeros are actually zeros of the polynomial or not. You have to just replace the x with the given value. Like let's say if I consider this one, we have this p of x, which is what? X plus 1 and x minus 2. Just solve this one first. So you guys see this is x plus a, x plus b type, considering this can be like this, right? So it will be what? X plus a, x plus b, x square, a plus bx plus ab, right? So it will be what? X square plus a is 1, b is minus 2 plus 1 into minus 2, right? So it will be what? X square, and there should be an x here. So this will be what? X square, this will be minus x and minus 2. Now you have to do what? Just put the values that have been given to you. If you end up getting 0, that will be 0. If you don't get 0, then that is not the value which should be giving you a 0. So if I substitute that to be negative 1, what do we have? Let's see. Square of negative 1, minus 1 and a negative 2. So you guys see this will be what? 1, minus 1, minus 2. So this should be what? 1 minus 3, that will be minus 2, which is not equal to 0. So this is not a value, this is not a 0. So if I put p of 2 now, this will be what? Square of 2 minus 1 minus 2. So this will be what? If I solve this, I will be having a 4. 4 minus 3, that will again be 1. So both of these values are not zeros of the given polynomial, right? Actually that should be 0. Let me see if I have made any mistake here. That is negative 2, that will be negative 1, and it has to be. See, if I just put it here, I think there is some error here. Although if I observe this one, I think I've done some calculation mistake. Let's see. X minus 2. If I just randomly replace it here, x square minus 2x, that will be x and that will be negative 2. So this will be x square minus x minus 2, right? So if I substitute negative 1, so that will be what? If you just put it as it is here, then your answer will be 0. If you put it here, it will not be. C. If I put it here, x plus 1 and x minus 2, this is my p of x, right? So if I put it like this, p of minus 1, this will be what? Minus 1 plus 1, x minus 2. So you guys see this is 0. So your answer will be what? It will be 0. Although if you have put it here, it will be what? 1 minus 1 minus 2. So it will be minus 2. There is just a difference in calculation. So try to put the value here. So if you put it directly here, then you will be getting zeros. If you just multiply them and then solve them, then you will not be getting 0 here. That is the condition here. I think there is something with this question. So this is the point. So if you put x equals to 2, so if I put it 2 plus 1, this will be what? 2 minus 2, it will be 3 into 0, that will be what? 0 again. So if you just solve them, then you put the values, then you will be getting error. Those will not be the zeros. Although if you put it like that, if you don't multiply them, then you just put the values, you will be ending up getting both of the values as the zeros. So just keep an eye on this question. You have to do what? You have to not multiply them, you just have to put the values here. So this is how you're going to attempt this one, right? Now let's see what do we have in the fourth one. So similarly, you can do each of these, right? Quite easy questions. So this will be homework as well. So we have to find out zeros in our fourth part. You have to do what? Just put them against 0 and you will be getting the value of x. Quite easy, like 2x plus 5, put it against 0. X will be what? Minus 5 by 2. So you guys see your zeros will be what? Let's just write it here. Putting it against 0, that will be minus 5. Putting it against 0, that will be 2 by 3. Putting it against 0, that will be 5. Putting it against 0, x will be 0. Putting it against 0, minus 5 by 2. Putting it against 0, x will be 0, because it has been given to you that a is not equal to 0. So 0 by a will be what? It will be 0. If you put this one, your x will be what? Minus d by c. So these are the zeros here. I hope you guys have understood each and every concept till now. So this is the whole point, and here I will be ending our video. I just haven't had our summary portion here, right? I just skipped that slide. So remember what we have understood in this case. I will be writing summary here, no worries. You guys should be recalling each and everything. So what are your algebraic expressions? These are your alphabets, or you can say your variables, which are used to denote some quantity which is not yet disclosed to you, like your 2x, your 3x, your 4x plus 1. So if you use your constants, your variables and your coefficients together in the form of a statement that is denoting actually a statement, that is the mathematical statement here, that will be what? That will be your algebraic expression. Then we had understood what is the degree. So the maximum power one variable shares, that is its degree. When we had more than one variable, so we had to look for that common term in which we had just added their power. If that power had been the maximum degree in that equation, that would have been the case, right? Like this one, 2x plus y plus 2xy. On looking at this, you will be having a maximum degree 1, like this is 1, this is 1. But if you observe these two, adding their powers, your maximum degree will be 2. So degree actually will be what? It will be 2. Remember this case? So this is how we have learned in this case. And then we had what? Then we had understood variables and coefficients and everything. You guys remember what are those? And later we had found out the cases of zeros. So zeros were what? Those were the values while you have, if you had been given any polynomial and you had replaced x for any value, and on that particular value your entire polynomial had ended up being 0, then that value was the 0 of the polynomial. So remember, zeros are generally those finite values of x at which your whole polynomial is 0. So that is the whole point here. Till here we have just completed our two exercise 2.1 and 2.2, and we have just understood the concept of zeros. So remember, this session is very important if you want to move further with this chapter, because this chapter is very easy and scoring one also, you cannot skip anything. So remember, you have to practice till 2.1, and I'll see you in the next session. That will be tomorrow. We will be having our exercise 2.3. There we will be understanding the case of our remainder theorems, our factor theorems also. That session is also very important. Just don't skip that one. I'll see you then. Till then, practice as much as you can. Bye for now.